Hello students, welcome back to Tuition Masters, and today we are going to discuss the NCERT questions of the chapter Structure of Atom. So, our first question is, compare the properties of electrons, protons and neutrons. So basically in this question what we have to do is that we have to compare all the properties of electrons, protons and neutrons, correct? Firstly, what are their charges? Right, here it is negative charge, here it is positive charge, here it is neutral charge. Correct, first point can be charges. Next is about their weight. Here in electrons the weight is almost like negligible only. Here proton, it is 2000 times of the electrons, 2000 times of the electrons is protons, and neutron is just same to protons only. So that is the second property. And what is their location? Here it is present outside of the nucleus, means in the orbits. The electrons are present in the orbits, whereas protons and neutrons are present inside the nucleus. Both of them are present in the nucleus, right? So here how you will compare the properties. Here is the entire table how you're going to write it as. Next is, what are the limitations of J.J. Thomson model of the atom, the plum pudding model? What are the limitations? What were the demerits? First one was that first thing could be that stability of the atom, right? Stability of the atom wasn't shown here because it was just about a sphere. Inside that electrons are there, only that much was explained, correct? Even no nucleus was there. Nucleus, about nucleus discussion, that was also not there in J.J. Thomson. It came in Rutherfords model. And also it doesn't explain the reason for positive and negative charges binding together. Positive and negative charges binding together, that is also how is it happening, not explained. So these were the limitations. So here I have explained it in the proper manner. Next is the next model, Rutherford's model, the model which had nucleus and all those things with the gold foil experiment. What are the limitations of this model? Now, Rutherford model was quite good, but again, here also stability. The stability of atoms was not explained. Even as we studied that due to acceleration, the electrons may go and fall into the nucleus. Correct, but that were things also were not explained, and he just argued that electrons are in the circular path; they move in the orbits. Okay, but this revolution can produce energy. So how is that energy coming? It will make the atom unstable. How was it? It was not at all explained. So that's why Rutherford's model was also not working out. Describe Bohr's atomic model. So here I've explained it just one slide. Describe Bohr's atomic model. Just have to explain, like he had positive charged nucleus he made, in which protons, neutrons are present, and the main thing is that he made four shells or four orbits as well. That in an atom there are four shells: the K shell, L, M, and N shell. So here how you will explain it. Next is compare all proposed models of an atom given in this chapter. So means you have to compare Thomson's, Rutherford's and Bohr's model. So for Thomson I'm just writing Thomson's, for Rutherford's I'm writing R, and for Bohr I'm writing B. So how will we compare this? Firstly, when I talk about Thomson, the plum pudding model, what did he explain? That positive, negative, both ions are embedded. Correct. Positive, negative, embedded. Right, I'm just writing in short, you'll get it ahead. So embedded, they are embedded in the atoms only. Only that much, and there were many demerits also. In Rutherford's again, he also said that they revolve. Correct, they revolve in their orbits, But again, radiation of energy was there, so that was also explained. He also explained that the all the positive ions are embedded and nucleus, and in the nucleus, and the negative ions, the electrons, are revolving. That he explained. And Bohr explained that electrons are the negatively charged particles, and they move in the orbits. Correct, they move in the orbits, and there is no energy generation in the electron revolution. In the discrete orbits, as explained, discrete orbits, no energy will be produced. So these were the all comparison of all the three models in this chapter. Here is the entire table. Next is summarize the rules for writing of distribution of electrons in the various shells for the first 18 elements. Now, first 18 elements, if you look in your NCERT textbook, they have mentioned all the electronic configuration. Now, what we have to do is that we have to write the rules. So we know that the first rule is that it is done by the formula 2n square. In one shell, how many will be there? It's done by 2n square. Correct. Next is for like first orbit there will be only 2. For k only 2 will be there. Then for L orbit there will be 8. For third orbit M it will be 18, and so on. And second one is that outermost orbit, the last orbit, orbit N, can only hold 8 electrons, maximum of 8 electrons only it can hold. And the next rule was that these shells will be filled in electrons in a stepwise manner. At first the first inner shells, and then outer shells. Like first K will be filled, then L, then M, and then N if required. So here is how the explanation was. Next is define valency by taking examples of silicon and oxygen. So see here, what we have to do here is that now valency we know is what? The number of electrons in the outermost shell. Correct. The number of outermost shell means what? The valence electrons. Number of valence electrons, that's it. Correct. And we know the rules also, the octet and all those things. Correct. So valence is number of valence electrons. Now in the case of silicon, okay, now listen carefully. In silicon, the now just write here silicon. So in the case of silicon, there are the in the outermost shell there are 4 electrons. Okay, there are 4 electrons. Now if the number of electrons in the outermost shell of the atom will be less than or equal to 4, then what will happen? The valency will also remain 4. So therefore the valency of silicon is 4 only. But when I talk about oxygen, there are 6 electrons, 6 valence electrons. Now as I had explained, if the if the number of electrons are more than 4, so what you have to do, you have to subtract it from it. This means that the valency of oxygen will be 8 minus 6, which is 2. So therefore these were the explanation. Next is explain with examples what is atomic number, mass number, isotopes and isobars, and even the two uses of isotopes. Now see, this is quite easy. You can refer to the last class notes also. Here also I've explained. I'll just explain you with the solution. See here, atomic number, we know what is it. It is the total number of protons, positively charged particles, okay, present in the atom. That is the atomic number. For example, oxygen has 8 protons, so the atomic number is 8. Mass number is the sum of protons and neutrons. Protons plus neutrons give us the mass number. So protons of oxygen, when it of oxygen, it has 8 protons and 8 neutrons. 8 plus 8 is 16, so the mass number is 16. Next, isotopes. Isotopes are what? They're atoms, same element, same atomic number also, but different mass numbers. As I had explained, right? Same, they like for chlorine, as I had explained, even for carbon. So what happens? They have this. All the elements are same. They have the same atomic number also, but the mass number is changing. Like here also, the 3 isotopes of hydrogen: protium, deuterium, and tritium. I even explained for Carbon also, that there is carbon 12, carbon 13, carbon 14 isotopes. Also for chlorine also there are two. Correct. So those are the isotopes. And isobars are what? Two different elements. Okay, two different elements are there. They have the same mass number. Okay, atomic number is different, but the mass number are same. Like calcium and argon, these two are isobars. And the examples, two uses of isotopes are like, for example, the isotope of uranium. It is used in the fuel, as in the nuclear reactions and reactors. Uranium isotope is used. Similarly, for treatment of cancer in hospitals, isotope of cobalt is used. Alright, so this was this question. Next is Na plus has completely filled K and L shells. What do we mean by this? Now, atomic number of Na. So, when I talk about the atomic number of Na, that is 11. Means it has 11 number of electrons. Correct. Now, the electronic configuration, I'll explain that also. You will study more how do we write in ahead standard. So, electronic configuration of this is 2, comma 8, comma 1. This is the electronic configuration. Now, the electronic configuration Na ion. Okay, Na ion means what? Here, if I say K, we have the four shells at K, L, M, and N. This means this 2 is for K, this 8 is for L. Correct. Now, we know that for K, there can only be 2. For L, there can be 8, and so on with the formula of 2n square. We understood that. Now, here also K is 2 only, L is 8 only, so K and L shells are full. So that's why here is how it is explained. So here I have explained it more properly. Now here, next question is, if bromine atom is available in the form of say two isotopes, 79 Br35, 49.7%, and 81 Br35, which is 50.3%. Calculate the average atomic mass of bromine atom. Now we have to find the average atomic mass. Average means what? First thing is, we will use that this part. Correct. The 79, which is the atomic mass. Correct. So we will write the atomic mass. Okay, so 79 multiplied by how much percentage we have, which is 49.7%. Okay, and same we will do for the other one also, the other isotope, which is 81 into 50.3. Correct. And I will divide both of them by the 100. Okay, now what will we get is that when you calculate it, you will get it as 3926.3 plus 4074.3 divided by 100. And when you calculate it further, you will get it as 8000.6 by 100, and approximately it will somewhere around give us as 80.006, that is approximately again 80 units. So 80 U is the average atomic mass of the bromine atom. Now, the next is the average atomic masses of a sample of an element X is 16.2 U. What are the percentages of isotope 16x8 and 18x8 in the sample? Now, we have two isotopes over here, correct, of the sample X. So, now we have to calculate what? We have to calculate the percentages. So let's do it with the solution. Now here we have the average atomic mass is what? 16.2 units. It's already given to us. Okay. Now let's take that the first isotope, the second one, 18x8. Let's take that a percentage of this is Y. Okay, so what will be the percentage exactly then? So it will be 100 minus Y, right? Now, similarly, the average atomic mass of element X will be what? It will be nothing but atomic mass of 18x8 plus, sorry, multiplied by the percentage plus the atomic mass of the other isotope, which is 16x8 multiplied its percentage, right? Now, what we'll do is Here we will do the calculation. 16.2. What is 16.2 over here? It is the um, at average atomic mass. 16.2 multiplied by 18 into y percent. So y is the variable we have and 18 is the top one atomic mass which we have, right? And we'll calculate them, and then you can see how we do the calculations. It's simple only, nothing difficult. So we'll get the percentage of x 16x by 8 of that isotope as 10, and 16x8 the isotope of that will be 100 minus 10, which is 90. So these will be the two percentages. Now next is, if z is equals to 3, what is z now over here? It is the atomic number, correct? So z is the atomic number that we know. Now we have to find the valency of the element and even name this element. What is that element and what will its valency be? Now we know that the atomic number is z. So what will be the electronic configuration? The electronic, I'll just write here, electronic, I'm just writing in short, configuration will be how much? It will be 2 in the K shell and 1 in the L shell, right? So 2 by 1. Now this 2 by 1, only one element has this, which is Li, that is lithium. So only lithium has an electronic configuration of 2 comma 1. So here is how you will do it. Now the next question is question number 13, that composition of the nuclei of two atomic species X and Y are given as under. That in X and Y, protons are 6 and 6 and neutrons are 6 and 8. So what we have to do, we have to give the mass numbers of X and Y, and we have to even find the relation between the two species. Okay, so now how are we going to do this is, first is we know that the mass number is how much? Number of protons plus neutrons, correct? That will give me the mass number. So let's take that the mass number of X. Okay, mass number of X is what? The mass number of X will be 6 plus 6, that is 12, and mass number of Y will be 6 plus 8, that is 14, correct? Now we know that the atomic number, right? Atomic number is nothing but number of protons, correct? So what will be the atomic number of X? So atomic number of X is 6, and even the atomic number of Y is also 6. So these two atomic species X and Y, they have the same atomic number, correct? If you look at it carefully, atomic number is same in both of them, but the mass number is different. So what are they called? These X and Y are nothing but isotopes. So they are nothing but isotopes. So here is your calculation. So thank you so much everyone for watching today's video. Don't forget to like, comment, share and even subscribe to our channel. And in the next video, we are going to start with the next physics chapter, which is work and energy. So don't forget to hit the bell icon so that you get regular updates. Till then,